Hi y'all, Miss Bailey here to give you a quick little video explanation about what in the heck terminal velocity is. So before I give you an actual definition, I'm just going to give you a hypothetical. Let's say you're daring enough and you decide to one day jump out of an airplane. Let's say your chute doesn't open. What are some of the things you could do to lessen your force of impact as you hit the ground? So here you are, you're falling. Not the ideal scenario, right? What forces are acting on you? Definitely force of gravity. And in physics land, we assume perfect conditions, no air resistance. So with this being the only force acting on you, you would be moving down and you would also be accelerating down, meaning you're speeding up as you're falling. So this is typical physics land conditions, perfect conditions. In the real world, we have this force of air resistance that would probably act on us. I'm going to call it force of air. It's technically a friction force, but the label isn't super important here. So air resistance definitely acts on you as you fall, which makes your overall net force in this situation just a smaller version of gravity. So you would still be accelerating down. But maybe you're familiar with iFly, maybe you're familiar with skydiving. If I spread myself out and make myself kind of lay flat as I am falling, I can catch a lot of air. And if I do that, I can actually increase my force of air resistance. And if I manage to increase it to where it's equal to my force of gravity, it's the same amount as my force of gravity, what would happen? Well, the object wouldn't just stop midair. My velocity would not become zero. My acceleration would become zero. I would still be moving down, but I would no longer be speeding up. I would be moving at the same velocity the rest of the way down. So instead of, typically speaking, speeding up and just really drilling into the ground, if I manage to hit terminal velocity, I'm going to move at a constant velocity all the way down. I'm no longer going to speed up as I'm approaching the ground. This is what's known as terminal velocity. That last velocity, that final velocity that you accelerate, or that you no longer accelerate at, you move at that final velocity the rest of the time. You no longer speed up anymore. So when you see this word, terminal velocity, think constant velocity. And maybe you remember from any of the other second law or net force videos, if you see two different phrases, constant velocity, wow, I cannot write right now, constant velocity or at rest, I can assume in both of these scenarios that my net force is zero and all forces acting on me are balanced. Technically, terminal velocity would fall into this category too, because terminal velocity means you are no longer accelerating and moving at a velocity the rest of the time, at a certain velocity the rest of the time. The actual note slide looks something like this. It kind of explains everything I just explained in slide form. You can see free fall with air resistance. This is typically what you would look like as you were falling, but at terminal velocity, think constant velocity, and your F net is zero. Your forces equal each other.